Information visualization uses computer graphics and interactive animation to stimulate recognition of patterns and structure in large information spaces. It does so by exploiting the human perceptual system in ways similar to scientific visualization. In this videotape, Jock, Stu, and I are going to show you the use of information visualization to access information both by content and by structure.
A prototype system called the Information Visualizer is used to explore the use of 3D interactive animation for information access applications. The Information Visualizer runs in a 3D version of the room's workspace manager. Users walk around in a collection of 2D and 3D rooms and interact with artifacts that are abstract representations of information or information structure. There are visualizers for structured and unstructured information. This system is similar to an artificial reality system, but it's made to work with a conventional 3D workstation and mouse. Office workers are not likely to wear special equipment such as gloves and helmets. Even so, users are drawn into the 3D environment by perceptual cues and interactive animation. This visualization, called the cone tree, shows part of a Unix directory hierarchy. Each node is a directory. When a directory is selected, the tree rotates through the shortest path to bring the selected path to the front. The selected path is highlighted with the directory name. 3D is used to make more effective use of available screen space. A 2D layout of the same tree would not fit on the screen. The user would have to scroll through the 2D layout and wouldn't have a view of the whole tree. The 2D layout could be reduced to fit, but details would be lost. Interactive animation is used to shift some of the user's cognitive load to the human perceptual system. You can see this by looking at a selection done without animation. It takes several seconds to reassimilate the relationships between the parts. With animation, the perceptual system tracks the relationships because of object constancy. When the animation completes, no extra time is needed for reassimilation. If we walk into the next room, we see an alternative layout which allows text to be displayed for all nodes. This visualization is called the cam tree. As before, selection rotates the tree to move the selected path up to the front. Highlighting is done with color rather than text. Notice that the display provides a fisheye view because of 3D perspective and coloring. The objects of interest are larger, brighter, and closer than the other objects. Search is done by popping up a property sheet and typing in a search parameter. The simplest search is to look for files with some string in the file name. The result of the search highlights the directories with matching files, showing the relative search scores with a red bar on the node. You can examine a file by selecting it from a menu of matched files. The screen rearranges itself so that the text of the file appears in an editor buffer. Another way of looking at files is to walk into another room, which uses a perspective wall to display the files. The perspective wall is used to lay out 2D information onto a 3D segmented wall. The front segment is used for viewing details, and the side segments provide context. In this case, each node represents a file with its horizontal position determined by its date of last modification. Vertical position is used to indicate the class of the file. When a node is selected, the wall moves to bring the selected node to the center of the front section. As before, we have a fisheye view. We're using 3D to make better use of available screen space, and we use interactive animation to exploit the perceptual system's ability to track relationships between moving objects. In regions of the wall where there is too much detail, we can stretch the wall like a sheet of rubber to reduce clutter.
In this scenario, we show how to use information visualizations to help manage an organization. The example you will see is taken from parts of Xerox. This room shows an organization chart with the top 650 executives from Xerox as of last October. This chart shows the same information that was contained in an 80-page document. We will focus on the corporate research group. If we prune away the parts we're not interested in, we see Bill Spencer's organization. Next, we want to look at the operating plan for that organization. This room shows a partial operating plan with layers for portfolios, programs, and projects. Each program and project has a narrative associated with it. Information access is done on those narratives. For example, we can take the narrative for the User Interface Research Group, shown here, and search for all narratives similar to this one. The results actually led us to discover a related project in another Xerox Research Center we were unaware of. During early stages of operating plan development, we may want to rearrange this tree. 3G object manipulation mechanisms let us do that. In addition to the operating plan, we have a database of highlights from the previous year. The highlight wall is another perspective wall showing highlights or milestones from programs in the operating plan. Each node is a highlight. Its horizontal position is determined by the date of the highlight. Vertical position shows which program the highlight came from. A typical search here is to use a highlight to look for similar highlights. We now have visualizations for who people report to, what they plan to do this year, and what they did last year. We also need a visualization of where people are. The next room shows where people in the System Sciences lab are at Park. The buttons at the top of this scene allow the user to select groups in SSL and find out where they're located on the floor plan. After selection, the offices for people in the selected group are highlighted. You can find someone's office by selecting their photograph. This room shares a database of biographies with the organization chart room. The most revealing search is to look for other people with biographies similar to a selected person's biography. This is the 3D rooms overview. Like a rooms overview, it shows all the rooms that are available. However, it is also active. Everything that you can do in a room, you can do from the overview. To summarize, information visualization exploits the human perceptual system using 3D visualization and interactive animation. Scientific visualization stimulates the recognition of patterns in data. Similarly, information visualization stimulates the recognition of structure in information. The result is a new, more effective way to deal with large information spaces.